Okay, so we've talked a lot about quadratic functions. We're going to look at writing their equations based on the solutions alone. So we just need a few reminders about some key components of the quadratic function. For example, recall that y equals x squared plus bx plus c is what we call a standard form of a quadratic function. Solutions solve a quadratic function equal to 0. That is to say that our solution is x equals a. Factors are the values that multiply to c and add to b, and the factor is essentially the product of the two linear factors. It's what creates the quadratic equation. So we have two things. Notice our solutions and our factors are always the opposites of one another. And the other thing is that solutions solve the quadratic equation, and factors help us to set up the quadratic equation. So we're going to look here. Suppose we have two solutions. So what I'm going to do is I'm going to say my first solution is x equals a, and then my second solution is x equals b. So these are my solutions, which means their factors would look something like this. I solved them both equal to 0. So x minus a equals 0 and x minus b equals 0. All I did was manipulate the solutions to turn them into factors. That means to write this equation, I would say something like this. Y equals the first factor, which is x minus a, times the second factor, which is x minus b. And if I were to distribute these out, I would end up with something that looks like so. So I'd have y equals x squared, and then I would have plus negative a minus bx, and then plus ab. Now that does not look pretty. That's just the algebraic representation here of the product of our factors. But notice it preserves this general shape. So we have the x squared, our leading term. Then we have just the x term, and then we have the constant term. So that's the algebra behind it. And that's when we have two separate solutions. Now, suppose we just have one solution. We say x equals a is a double root, which means if x equals a is the solution, the factor would be x minus a equals 0. So then again, to create my equation, I'm going to do y equals, and then I'll have x minus a. But since it's a double root, I'm going to have x minus a second time. And the same logic would follow. We would distribute this out, and we would have this equation here. And we could actually clean this up to look something like so. And I'm going to be completely honest, this is not a pretty equation. Neither one of these two are pretty. This is just the algebra behind what we'll be doing. So let's take a look at an example in practice. Just give me one moment here to adjust my screen. Okay. So suppose we have the following pieces of information. I am told that I have the two solutions, x equals 5 and x equals 3. These are my two solutions. So what has to happen now is that I have to write the equation from these. Well, again, these are my solutions, which means that my factors would be the opposite. That means that x equals 5 solves the equation x minus 5. X equals 3 solves the equation x minus 3. So notice that my solutions and my factors always have the opposite signs here. So what I'm going to do now is I'm going to do my box method to figure out what this quadratic equation would be. I'm just going to draw my box here, and I'm going to write in my two monomials. So I have x minus 5 and x minus 3. It's like a Punnett square model from biology, so I'm just going to take their respective products. X and x will give me x squared. Negative 5 times x will give me negative 5x. X and negative 3 will give me negative 3x, and negative 5 and negative 3 will give me a positive 15. Combining my like terms, I get the following quadratic. X squared minus 8x plus 15. This is my equation, because notice the two factors for this would be x minus 5 and x minus 3, and then our solutions are x is 5 and x is 3. So you're basically going in reverse here. So normally we go from our equation to factors to the solution. And now we're going backwards. We're using the solutions to find the factors in order to find our equation. So I'll let you do the example on the right there. Let's do a different example where we have two different signs. So if I look here, x equals -2 solves the equation x plus 2. X equals 1 solves the equation x minus 1. So now I have my two factors, and I got those from my two solutions. And I'm going to take a box here, and I'm going to find what my original quadratic function was. So again, I replace the top with my first monomial, x plus 2, and then I replace the side here with my second monomial, x minus 1. Then we find the respective products. X and x will give me x squared. 2 and x will give me positive 2x. X and -1 will give me a negative x, and 2 and -1 will give me -2, which tells me the function here would be y equals x squared plus x minus 2. And if I wanted the factors, that would be the red. Positive 2 and -1, if I sum those together, I get positive 1. And if I do 2 times -1, I get -2. So again, we're just working backwards. We have the final answer, and we're looking for the solution. I mean, not the solution, sorry. We have the solution, we're looking for the original equation. So I'm going to adjust again really quickly here, and you all can definitely do the other two examples on the side there. Let's look at a double root example. So if I know x equals 1 is a double root, that means x equals 1 is a solution 2 times. Since it is a solution 2 times, that means x equals 1 is the solution to the factor x minus 1. And it's a double root, so that means x minus 1 occurs 2 times. So what I'm going to do again is I'm going to draw out my box here. I need to figure out what this original factor is. So we take the equation x minus 1 times x minus 1. Again, we find our respective products, and it'll look something like so. And we get that our original quadratic equation here would be x squared minus 2x plus 1. So this is just a little bit of information on how, when we're given solutions, we can find their equations. First, we find their factors, and then we find the product of their factors. So typically, we go from the box to the red to the solution. But now we're going backwards. We're going from the solution to the factors to the original quadratic equation.